Good day, class. Today we are going to look at the first 20 elements. And after looking at the first 20 elements, we are going to look at how do you know if an element is a metal or non-metal, because basic classification, there are some elements that are metal, there are some that are not metal, there are some that are metalloid. So how do we know? So basically, let's classify element first into metal and non-metal. So we want to know how to distinguish if an element is a metal or if the element is non-metal. Now, these are the first 20 elements. These are their symbol. Calcium is Ca. Calcium is Ca. Now, let's know how to distinguish if an element is a metal or non-metal. Now, before we proceed, there is what we call an altered state. An altered state or duplet electronic what? Structure. There is what we call an altered state. There is what we call an altered state or duplet electronic structure. What does that mean? Every element, they want their atmosphere to be exactly 8 electron or what? 2 electron. They want their atmosphere to be exactly 8 electron, 2 electron. Let's take, for example, let's take any example we like. Let's take of oxygen. This is oxygen. What is the atomic number of oxygen? It's 8. Now, let's write the electronic configuration of oxygen, which is what? 2.8. 2.6. So the first share of oxygen takes what? 2. Subsequent share takes a maximum of 8. But if it's not up to 8, you have to write 6, because 2 plus 6 is equal to 8, which is equal to the atomic number of what? Of oxygen. So now oxygen will say, okay, now my atmosphere is exactly 6, but I need 8 to make it to alter an altered state. An altered state is a state whereby an element has exactly 8 electron or 2 electron, just like in the case of what? In the case of neon. So now, in respect to oxygen is going to gain what? 2 electron. Oxygen is going to borrow and gain what? 2 electron. Oxygen will be what? -2. That is why you see O2. Now, let's take another example. Let's take magnesium. What is the atomic number of magnesium? The atomic number of magnesium is what? Is 12. Magnesium atomic number is 12. Now, let's proceed. So, it will now be 2.8 dot what? 2. 8 plus 2. 10 plus 2 is 12. So now, magnesium, the atmosphere of magnesium is what? Atomos electron. There are 2 electrons in the atmosphere of magnesium. Magnesium will do away with these 2 electrons. It will now be plus. That is why you see Mg2 plus. In most cases, you see Mg2 plus. That is why you see Mg2 plus. So now, magnesium, anytime you see plus, it means that element is a metal. Look at oxygen. It's a metal. That is how you say if an element is a metal, it's a non-metal. I want us to continue to proceed and do more example. Let's look at calcium. This is calcium. This is calcium. This is the symbol of calcium. Let's write the electronic configuration of calcium, which is 2.8 dot what? 2. Let's proceed. 16 plus 4 is 20. So calcium has 2 electrons in its atmosphere. So calcium is going to what? Borrow it out. You throw it away. So calcium will be what? Positively charged. Calcium is a metal. Calcium is what? It's a metal. This is calcium ion. This is a calcium ion, charged calcium ion. Now, let's look at neon. I want us to take a look at neon because all elements behave differently. All elements, they don't behave in the same way. Element behave according to what? The atomic number. That is why the periodic law states that property of element are periodic function of what? Of the atomic number. That is a different topic, which is periodic table. We are going to treat that topic specially. So let's look at let's look at neon. This is neon. Atomic number of neon is what? 10. Now it will not be 2.8 dot what? Is 2.8. So don't forget, the aim of every element is for them to have 8 electrons in their atmosphere. The aim of every element is for those elements to have how many electrons? 8 or 2 electrons in their atmosphere. Now it's like you want a calculator. You are sitting in a place. You are with the calculator ready. You don't need to step aside. You will continue to be there because you no need for you to move. So that is why these elements, they don't react. They are inactive. They are noble gases. We call them what? They are called noble what? Noble what? Gas. This is a noble gas. They don't react. They behave like king, before they do anything. Sure, the atom is very stable because they have obtained what we call an altered state. Neon has obtained what we call an altered state or a duplet electronic structure. Neon has obtained what we call an altered state or a duplet electronic structure. So that is how to see character. So this element now is not reactive. So now let's draw diagrammatic representation. So this is the nucleus of neon. So first shell takes a maximum of 2. Second shell takes a maximum of what? Of 8. And it has 8. 1, 2, 3, 4, 5, 6, 7, 8. 2.8 neon. This is neon. It's a noble gas. It's a noble gas. This is neon. It's a noble gas. Let's continue to look at more elements. Let's look at other elements. Please, let's take a look at fluorine. Fluorine atomic number is 9. Atomic number of fluorine is 9. So this is fluorine. Atomic number what? 9. Which is, let's draw the electronic configuration of fluorine. 2.7789. So chlorine, this is chlorine. Don't forget, this is chlorine. So chlorine will now be 2.8.7. This is the electronic configuration of chlorine. What do we say all elements? What is their aim? They want to attain an altered state. What is an altered state? An altered state is defined by the atomic share of an element must be exactly 8 electrons or 2 electrons. What is an altered state? An altered state is a state whereby the atomic share of an electron of an atom or an element is exactly 2 electrons or 8 electrons. So all the elements in the periodic table, they want to achieve an objective. What do they want to do? They want their atomic share to be 8 electrons. That is what they are fighting for. That is just what they are fighting for, and that's why elements react. That is the desire, So now, fluorine, it has 2 electrons in the first shell. This is the first shell. This is N shell, and this is M shell. So now, what happened? You have 7, and you need 1 to complete 8. You have to borrow. That is why fluorine is minus what? 1. So fluorine is what? No metal. No what? No metal. Fluorine is what? It's a non-metal. Fluorine is a what? It's a non-metal. Let's look at, please, let's take note of the ion. Don't forget, the other time we saw that oxygen is what? -2. Then we proceed, we discover that we look at fluorine ionization. When it's ion is -2, we look at neon. Neon is not charged because it has 8 electrons in its atmosphere. Neon has how many electrons in its atmosphere? 8 electrons. And that is the desire of all the elements. They want to obtain an octet state or a duplet electronic what? Structure. All the elements want to obtain what we call an octet state or a duplet electronic structure. Okay, so let's proceed. Now, an octet state can be attained in 2 ways: by gain of electron or lose of electron. An octet state can be achieved in 2 ways: either by gain of electron or by what? Lose of electron. Now let's proceed. Let's look at something like an element like potassium. Potassium, the symbol is K. So this is symbol 2.8.8. 8 plus 8, 16, 16, 17, 18. 16, 17, 18, 19. So the atmosphere of potassium has only what? How many electrons? 1. So let's draw it. Let's draw the electronic configuration. Electronic configuration of what? Of potassium. Now, let's go. This is the nucleus of potassium. First share takes a maximum of what? Of 2. Let's spread it. Second share takes a maximum of what? Of 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 2.8. We have another 8. Let's proceed with this 8. Now, second share takes a maximum of what? Of 8. And we have 8 here. 1, 2, 3, 4, 5, 6, 7, 8. Now, last year has 2. It has 2. It has 1 electron. So now, potassium is going to do away with this 1 electron. So potassium will now be what? Positively what? Charged. Now we have potassium with what? Positively charged. That's why we have potassium ion. That's why we have what? Potassium ion. Let's quickly look at chlorine. Let's look at chlorine. This is chlorine. Atomic number of chlorine is 17, which is 2.8.7. 2.8.7. Now let's proceed. It now be first share takes a maximum of what? 2. Second share takes a maximum of what? 8. 1, 2, 3, 4, 5, 6, 7, 8. Now the last share takes a maximum of what? 7. 1, 2, 3, 4, 5, 6, 7. Now chlorine will borrow 1 to make it what? 8. So chlorine, if chlorine borrow 1, chlorine will not be what? Minus, which is, that's why I see minus. So any element that is negatively charged is not metal. Any element that is positively charged is what? Is a metal. In the case of potassium, potassium is a metal, chlorine is not metal. And this is the basis at which elements combine with each other. This is the basis at which element combines with what? With each other. Now, I want us to look at briefly how this element combine. Let's look at it briefly, how this element will combine. Now, before we proceed, let's take a look at when magnesium reacts with chlorine. It's going to give magnesium chloride. Magnesium is a metal. Chlorine is not metal. Normally, when metal react with chloride, they form salt. Magnesium chloride is a salt. But I want us to look at it, how this octet state play that in a reaction. What happened? Let's look at it right away. Let's look at it. Now, when magnesium reacts, magnesium is a solid. When magnesium reacts with chlorine, it's going to give what? Magnesium what? Chloride. When magnesium reacts with chlorine, it's going to give what? Magnesium chloride. When magnesium reacts with chlorine, it's going to give us magnesium chloride. Now, let's balance our reaction before we proceed. Magnesium is what? 1 here. Magnesium is 1 here. Chlorine is 2. Chlorine is 2 here. In the reactant, we have 1 more of magnesium. Product, we have 1 more of magnesium. Magnesium is balanced. The equation is balanced. Now let's proceed. I want us to look at what actually happened in this reaction. Let's look at what actually happened in this reaction. That's what we're going to look at. Now, before we proceed, electron that take part in the reaction are electron in the atomos shell of an element. It is only the electron in the atomos shell of an element that takes part in the reaction. In the case of magnesium, we know the atomic number of magnesium is 12. Is 12, so it might be 2.8.2. Now, we know in the case of chlorine, the atomic number is what? 17. So it might be 2.8.7. So now, these 2 electrons and these 2 electrons will take part in this reaction. And don't forget, magnesium, the atomos share here is 7. So magnesium is going to take, chlorine is going to take 1 to make it 1. So magnesium is going to take an electron, making it to be what? 8. So those are the electrons that take part, atomos electron that take part before the product is going to be formed, which is the salt. Now, in some reaction, most chemistry students are worried. Instead of writing chlorine as single, lecturer only write it like Cl2. Why? Let's look at why it's like that. Normally, chlorine, or 1 atom of chlorine is not stable in air. It combines with another atom of chlorine to form Cl2. That is why chlorine is Cl2. Now let's represent it diagrammatically. I want us to represent it diagrammatically. But before we represent it, let's remember that it is only the atomos shell, the electron in the atomos shell that takes part in the reaction. Now, if that is the case, don't forget, chlorine has how many shells? It has 3 shells. Don't forget, it's 2.8.7, right? So we are talking about the shell. This 7, 1, 2, 3, third shell. So let's proceed. First shell takes a maximum of what? Of 2. Second shell takes a maximum of what? Second shell takes a maximum of what? 8. 1, 2, 3, 4, 5, 6, 7, 8. 2.8.7. So we are looking for, we want to add several electrons to make chlorine to be complete atom. So 1, 2, 3, 4, 5, 6, 7. Please, before we continue, we should not forget, before 2 atoms will combine together, they are looking for something. There's what we call exchange of electron or sharing of electron. 2 things: exchange of electron or sharing of electron, and that is the basis at which chemicals combine together. I'm talking about atoms. That is the basis of chemical combination. Now, chlorine, this atomos share, it is only the atomos electron that combines. It is only the atomos electron that combines. No other electron can combine because the electron inside, the energy required to bring them out is pretty very difficult. So let's proceed. So chlorine plus 1, 2, 3, 4, 5, 6, 7, 8. Now the last chair. 1, 2, 3, 4, 5, 6, 7. So you can see we have 2 electrons here. So these 2 electrons is going to, they will combine together. They will combine together in the product side. So because of that, since it is only the atomos share of the element that is reacting, which is the atomos electron, let's draw electronic configuration of the 2 atoms of fluorine. Don't forget, this is one atom, this is another atom. So now let's represent it diagrammatically. Now this is the atomos share. This is the first one is N, M, N. So we are talking about the N share. So before we proceed, we are talking about the electron in the atomos share. So now let's proceed. This is 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That is why we have Cl2. That is why we have what? Cl2. That combination is as a result of 2 atoms of chlorine combined together, because normally chlorine is not stable in air. It combines with another atom of chlorine to make it to be very stable, and this is the form at which chlorine reacts. This is the form at which chlorine what does react. We'll look at more example. So initially, I make a statement that when metal react with what? Chloride. When metal react with halogen, they are called salt formers. Bromine, chlorine, iodine, fluorine, they are what? They are salt formers because they form salt. When metal react with them, they form salt. So we are going to take a metal and react with, okay, let's say that sodium is a metal. We are going to react sodium with what? Chlorine. It's going to give us salt. That is what we call table salt. So when sodium react with what? Chlorine, it produces what? Sodium chloride. It produces what? Sodium chloride. So let's look at it together. This is sodium plus what? Chlorine. It gives what? Sodium chloride. Now, let's represent it diagrammatically. Now, sodium has 2 electrons. Let's 2 dot what? What is the atomic number of sodium? The atomic number of sodium is what? 11. So 2.8.1. 10 plus 1 is 11. What is the atomic number of chlorine? 2.8.7. Now, it is only this atomos electron that will react. It is only this atomos electron that will react. So sodium is going to give this electron to what? To 7 to make it 8. Sodium will give out this atomos electron to chlorine to make, then if he gives it out to make it 8. Now this atom of sodium will be empty. Automatically 8 will be here and 8 will be here. I want to explain again. I want to calm down and explain this concept. The reason why elements combine is that they want to obtain an altered state or a duplet electronic structure. I am giving an example using when sodium reacts with chlorine. Now, what is the electronic configuration of chlorine is what? 2.8.1, because atomic number of chlorine is what? Is 11. So let's draw it 2.8.1. Now, what is the atomic number of chlorine? Atomic number of chlorine is 2.8.7. Now, before we proceed, when an element has exactly 2 electrons or 8 electrons in its atmosphere, no need for the element to react. It means the element is very stable. It's just like in the case of neon, which I mentioned earlier. Let's look at neon. Ne 2.8. Atomic number of neon is what? Is 10. Atomic number of neon is what? Is 10. Now, I want us to look at this reaction properly. When sodium reacts with chlorine, what happens? It produces what? Sodium chloride. I want us to look at what happened. What actually happened at the atomos electron of the respective element, that is sodium and chlorine. Now, let's proceed. Before we continue, don't forget, it is only the electron in the atmosphere of an element that takes part in a chemical reaction. It is only what? The electron in the atmosphere of an element that takes part in what? In a chemical reaction. The electron in the other shares don't take part. Now, before we proceed, before we can get it very clear, is that we must draw the electronic configuration of what? Of sodium when it reacts with chlorine. So now, let's take the one of sodium. First here takes a maximum of what? 2. Second here takes a maximum of what? 8. And we have 8 here. 1, 2, 3, 4, 5, 6, 7, 8. Then last here takes just, it has 1. Now, when it combines with chlorine, first here this is 2, right? 1, 2. Now, this is what? 8 electrons. So let's draw another share. 1, 2, 3, 4, 5, 6, 7, 8. Now, this is the first, second, and third. Let's go to the third chair. Third chair, 7. 1, 2, 3, 4, 5, 6, 7. So let's proceed. But before we proceed, you will notice that when you add all the electrons in the atmosphere of chlorine is equal to 8 now. When you combine it, that's what we are going to see the other end. So it will now be first share takes a maximum of now first here takes a maximum of what? Of 2. But now at this point we are talking about the atmosphere. So for sodium we have only 1. For sodium we have how many? 1 here. Just drop it here. So chlorine has 7. Add your 7. This is sodium and this is your what? Your chlorine. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 5, 6, 7. You can see there is what we call altered state. When sodium, because sodium reacts with chlorine, they have altered and altered state. That is why you have 8 electrons in the atomic share of chlorine here. 1, 2, 3, 4, 5, 6, 7, 8. Now, when sodium reacts with chlorine, they form a stable what? Covalent compound. When sodium reacts with chlorine, they form a very stable what? Covalent compound. What are covalent compound? Those, when non-metal combine together, they form a covalent compound. When non-metal react with metal, they form electrovalent compound. Just like in the case of when sodium reacts with chlorine, it forms sodium chloride. Sodium chloride, the bond that exists between sodium chloride is what we call electrovalent bond. The bond that exists in what? In chlorine atom, which is Cl2, is what we call covalent bond. So in the case of when sodium reacts with chlorine, it is electrovalent bond. That is for one. And they are obtained what we call an altered state. Why do we say so? Because chlorine has 8 electrons in its atmosphere. Because chlorine has how many electrons? 8 electrons in its what? Atmosphere. It has obtained an altered state. Chlorine has 8 electrons in its atmosphere. So now, in this our studies, we are able to explain clearly why we know that there are some elements. We know, oh, this is a metal, this is not metal, because if you look at the charges and the method you will use is try and look at it from duplex and altered structure. When an element is charged, how do you know? Draw out the electronic configuration, transfer the electron, you will know if the element is a metal or not metal. No need to cram. But as you get used to those elements, once you hear the name of any element, you'll be able to tell, oh, this is a metal, this is not metal. But as we progress, one of the major take home in this our lesson is the major reason why element combine is because of an altered state or a duplex electronic structure. And what is an altered state? What is a duplex state? A duplex state or an altered state is a state whereby the element has exactly 8 electrons in its atmosphere or 2 electrons. And this is achieved by either gain of electron or lose of electron. By either gain of electron or lose of electron. And that is why we see sodium ion, sodium throw away 2. Don't forget, sodium is 2.1. When sodium throw away these 2, it become what? Positively charged. That's why you see sodium ion. When sodium throw away that, it become what? Positively what? Charged. It becomes sodium ion. I want us to look at when, let's take an example, when calcium reacts with oxygen. When calcium reacts with oxygen, what is the reaction? It's going to form calcium oxide. Let's look at it. When calcium reacts with oxygen, calcium reacts with oxygen to produce calcium oxide. Calcium oxide is a base. When metals are born in air, they produce oxide. We have many types of oxide. We have acidic oxide, basic oxide, like nitrogen. When nitrogen, those non-metal, they produce what? Acidic oxide. This is basic oxide. So now, when calcium reacts When calcium reacts with chlorine, okay, when calcium reacts with oxygen, is going to give us what? Calcium oxide. When calcium reacts with what? Oxygen is going to give us what? Calcium oxide. We are going to look at some features in this reaction. When calcium reacts with oxygen, it gives us calcium oxide. We are going to look at some features in this reaction. Now, before we proceed, what are the type of bond that keep oxygen together here? Normally, oxygen is not stable in air. This is the normal oxygen. It combines with another oxygen atom to give what? Oxygen what? O2. This is the oxygen that is stable. This is what is stable. So let's proceed. This is the oxygen that is stable. So now we have, which type of bond do we have here? We have covalent bond here because it is this oxygen is non-metal and this is non-metal, so we have covalent bond here. So when calcium reacts with oxygen, is going to give what? Calcium oxide. Calcium oxide. So let's balance the reaction. We have calcium 2 here. We have oxygen 2. We have calcium 1, oxygen 2. Let's make oxygen to be 2 here and calcium to be 2. The reaction is what? Is balanced because we have 2 calcium, 2 oxygen, 2 calcium, 2 oxygen. So this side, this is our reactant, and this is our what? Product. This is our reactant, this is our product. That is our reactant and that's our what? Product. So when calcium reacts with oxygen, it gives calcium oxide. When calcium reacts with oxygen, it gives calcium oxide. Now, what are we going to do now? Let's look at this reaction. What actually happened? Let's look at it in terms of chemical combination. In respect of electron in the atomos shell. In respect to what? Electron in their what? In the atomos shell. So now, let's proceed. This is calcium. 2 dot what? 8 dot what? 8. Atomic number of calcium is 20. So 16 plus 2 plus 4 is 20. Is 20. Reacting with what? Oxygen, which is 2.6. 2.6. Now let's proceed. Don't forget, it is only the electron in the atomos shell that reacts. Electron in the atomos shell that react. It is only the electron in the atomos shell. These are the what? Atomos shell electron. Atomos what? Atomos shell electron. These are the atomos shell electron. It is only the electron in the atomos shell that reacts. So now, let's proceed. So with that being said, now calcium is what? The atomos shell is 2. This is the nucleus. 1, 2. Then oxygen is what? Oxygen. This is the atomos shell, right? We are taking electron in the atomos shell and we are taking the shell. So now, normally calcium has how many shells here? It has 1, 2, 3, 4. It has 4 shells. Don't forget, it is only electron in the atomos shell of every element that react. That is why I brought down what? This shell down. I brought it down here. So this is the nucleus, react, plus this 6. This is nucleus 1, 2, 3, 4, 5, 6. Now let's combine it together. This is the nucleus. Now 1, 2, 3, 4, 5, 6, 7, 8. Now it's not 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, calcium chloride is not very stable. This is calcium chloride, very stable. This is diagrammatic representation of what? Of calcium chloride. This is the diagrammatic representation of what? Of calcium chloride. Very, very stable. From this reaction, we can see that calcium reacts with oxygen to produce calcium oxide. I balance the reaction for the sake of balancing of reaction C, because every reaction in chemistry must be balanced. As every reaction should be balanced. Now, this is your reactant, this is your product. Now, it is only electron in the outermost shell of an atom that react. Electron in the outermost shell, they don't react because they are pretty stable compared to the one outside. Take a look at, let's assume you have a warehouse. You are taking goods from the warehouse. It is only the goods at the end. Let's assume the warehouse is filled with goods. It is only items that are closer to the door you have to bring out first before you can bring out item inside the warehouse. That is how it is. So it is very difficult. It is very easy for you to take items from that are closer to the door, take them out, even though it is the one that is inside you want. So that's how the electron in the outermost shell reacts. Oh, this is a very nice topic. Chemical combination. And we also notice that neon does not react. That is why I want to ask a question. Have you ever seen whereby you say neon chloride, neon hydroxide, neon tetrasulfates, or neon potassium hydroxychloride? No, those things does not exist because neon is very stable. Neon is very, very stable. That is why they are called noble gases. They are very stable. Neon is very stable. Argon is very stable. Neon and argon, they are very stable. They are stable compound. The atomic shell is completely 8 electrons. Neon has alten and altered state. Argon has alten and altered state. Why do we say so? Why do we say neon and argon has alten and altered state? Because their atomic shell is completely 8 electrons. Look at helium. Helium has alten and altered state. Let's demonstrate it. Because helium has 8 electrons in its atomic shell, helium has also alten and altered state. That is why, are you not surprised? Have you ever seen helium hydroxide or helium chloride or helium? No, you can never see that. Those reactions are not feasible because it can never exist in the first place. Those reactions they are not feasible because it can never exist in the first place. Now let's look at even argon. So argon, atomic number 18, 2.8.8. It's a noble gas. Helium 2.0. It has 0 electron. It cannot react. What again? Neon, atomic number 10, which is what? 2.8. 2.8. So invariably it's either 0 in the atomic shell or 8. So because this guy has 8 electron, 2 electron, 8, 8, they are considered to be what? They are considered to be noble gas. They are noble. They are noble or inert. They are called noble or what? Or inert. They are called noble or they are called what? Inert. You know? They are called noble or they are called what? Inert. So with this, anytime we see any reaction, we'll be able to tell what is happening in such a reaction. We'll be able to tell. When sodium reacts with chlorine, it gives sodium chloride. When magnesium reacts with chlorine, when magnesium reacts with chlorine, what type of bond is that? When magnesium reacts with chlorine, when magnesium reacts with what? Chlorine, it's going to give what? Magnesium what? Chloride. When magnesium reacts with chlorine, it's going to give magnesium chloride. Now, let's look at this reaction together. Chlorine is one atom of chlorine, this one is not stable. It combines with another atom to form chlorine. Gas. They are not stable. If you combine with another, now the reaction is, you can see that the reaction is even balanced from here. So that is why we have this chlorine. That's why we have that chlorine. So let's proceed. When magnesium is a solid, when it reacts with chlorine, you're going to give magnesium chloride. Chlorine is a gas, solid. Now let's proceed. Magnesium 1, chlorine 2, chlorine 2. Now our reaction is balanced. So let's proceed. Let's proceed. What is the atomos? Let's draw the electronic configuration of magnesium, which is 2.8 dot what? 2. Now chlorine 2 dot what? 8 dot what? 7. 2.8.7, that is the electronic configuration of chlorine. 2.8.7. While the one of magnesium is what? 2.8.2. So let's look at it. When magnesium reacts with chlorine, what happens? It's going to give us magnesium chloride. Of course, you know this is a salt. You know it's a salt. Now let's proceed. What do we say? It is only the atomos electron that react. It is only the atomos electron that react. So it is only what? The atomos electron that reacts. You can see this is the atomos electron, and this is the atomos electron. And this is the atomos electron. But we should not forget, in this case, chlorine is what? Chlorine is 2. So let's proceed gradually. So we now have normally we have 2.8.2. So which is first share takes a maximum of 2, second share takes a maximum of what? 8. 1, 2, 3, 4, 5, 6, 7, 8. Then last share takes a maximum of what? 2. 1, 2. This is magnesium atom. When it reacts, it will react. Magnesium atom is going to react. So let's start from the beginning so that I want all the reaction to be on the board physically. So this is nucleus. First atom takes a maximum of what? 2. Second atom takes, second shell takes a maximum of what? 8, right? Good. 1, 2, 3, 4, 5, 6, 7, 8. 2.8 dot what? 2. Good. So we have 2 electrons remaining. So let's share it. Let's add it. 1, 2. So 2.8.2. Now plus chlorine. There are 2 chlorine here. One, let's put 1 here and 1 here. Chlorine is electronic configuration of chlorine is what? 2.8 dot what? 7. So let's proceed. It will not be first shell takes a maximum of what? 1, 2. Second shell takes a maximum of 8, right? So we have 8 here. 1, 2, 3, 4, 5, 6, 7, 8. Then the last shell 7. The last shell is what? 7. 1, 2, 3, 4, 5, 6, 7. We should not forget it combines. Let's not forget it combines with what? First shell takes the maximum of 2. Second shell takes the maximum of what? 8. 1, 2, 3, 4, 5, 6, 7, 8. Now the last shell takes the maximum of what? Of 8, but it has 7. It has 7. So 1, 2, 3, 4, 5, 6, 7. Now what we need to do now, let's take the atmosphere of chlorine. Let's take only the atmosphere of chlorine because it is only the electron in the atmosphere of chlorine that will react. So now we are going to take the atmosphere of chlorine, okay? So we will also take only the atmosphere of what? Magnesium. Now of magnesium, now we are going to, so we have three shares. We want to draw the diagrammatic representation of magnesium chloride. We want to draw what? The diagrammatic representation of what? Of magnesium chloride. So we now have, this is magnesium. This is magnesium. So now you combine with chlorine. You combine with another atom of chlorine. You combine with what? Another atom of chlorine. This is magnesium. So now this is magnesium Mg. So what is the atomic number of magnesium here? 2.8.2. So now let's take the 2 electrons. It is only these 2 electrons that will react. It is only these 2 electrons that will what? That will react. It is only what? That 2 electrons that what? That will react. It is only these two elements that will react. So let's add it, making it to be what? Okay, let's add another. Then let's add another 0. Get in the right. So this will be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That is why it's like this. Plus, we can see this is magnesium what? Magnesium what? Chloride. This is the diagrammatic representative of what? Of magnesium chloride. So in today's class, we can see that electronic configuration of atom is pretty very easy when we follow the appropriate standard. And what is the standard? If we know that the aim of every element is to what? Is to obtain an altered state or a duplex state, electronic structure. So see you next time in our class. Bye for now.